All right, this is a cool problem where we're going to use quadratics to maximize our space, right? We want to maximize our area of this given figure. Finding x value that would give us the most area if the figure looked like this. So find the value of x. So find what value we should be using for x to maximize, use the most spaces possible of the area of this figure. So let's imagine you're just building like an L-shaped garden and you want to make sure you take up as much space as possible. Well, you can do that by writing quadratics out after you find your area of each one of these figures. Now you're looking at that saying each one of these figures, there's only one, but we're going to actually break it up into two different parts here. So I'm going to just draw down here my smaller, more horizontal rectangle, and we know that the distance here, okay, all the way across, we're going to use the bottom, is 1.5x feet long. Now to find this distance from here to here, we need to do some thinking. The long distance from the top all the way to the bottom, that's 6 feet. But if you look at this side over here, if we remove x feet, so if we take away all of that, that's what's left, right there to there. So 6 is the total, but let's remove the x feet that we're not using. We're not using any of that, right? So we only want to be left with what's left over. So 6 minus x, right? 6 minus x would be this distance from here to here. Okay, so now that we've got a length and a width, we can just multiply those two together to find our area of this section of the figure. We still have this rectangle to deal with, so we're going to write that down over here. So I'm going to draw a more vertical rectangle for us. We know the distance from here to here is x. So I'm going to just label that as an x. But what's my distance on top, my distance on bottom? Well, that would be using this total length, 1.5x, but we gotta stop it right there. Remember, we're only trying to find this distance. So if the total's 1.5x, if we remove this portion that we're not using, x, from it, that's what we'd be left with. So this distance is gonna be 1.5x minus this distance here that's not being used of x. So I've got a binomial that I'm now going to be taking, multiplying it by this. So I got this binomial here that I'm going to be multiplying by the monomial there. That'll give me the area of this rectangle. And we've got our distance here and our distance there. So if we just multiply those two polynomials together, that's going to give us our area of the bottom rectangle. So let's do that. 1.5x times 6 minus x. 1.5x times 6 minus x. This is going to give us our area of the bottom rectangle that we're looking at. Okay. These two multiplied together is going to give our area of this rectangle up here multiplied together. So start by multiplying, distribute. 1.5x times 6, that's going to give me 9x. 1.5x times negative x is going to give me negative 1.5x squared. So this is my area of this one, 9x minus 1.5x squared. Now let's find the area of this one down here. So x times, remember just areas, length times width, x times 1.5x minus x, x times 1.5x minus x. These are like terms. Let's combine those. What's 1.5x minus x? That's just going to leave you with 0.5x. So if I distribute, boom, I'm going to get 0.5x squared. 0.5x squared. So here's my area of this one, 0.5x squared. This is my area of the other rectangle after we broke them up into two parts. So we've got two areas that we need to add together because we want the area of everything. And what's going to end up happening is we're going to get a quadratic. And what's cool is we can use that quadratic to find our maximum so we can maximize the amount of maximize the amount of area given the values we decide to use for x. All right, so 9x minus 1.5x squared plus 0.5x squared. 9x minus 1.5x squared plus 0.5x squared. These are like terms, so we need to combine those. Put them together. Negative 1.5 plus 0.5 just gives me negative 1x squared is what I'm left with. I've got a positive 9x. We're going to include that in. So we are dealing with this quadratic. Y equals negative 1x squared plus 9x. Now what we can do is we can find the vertex of this quadratic like we would find the vertex of any quadratic. Why do we want to find the vertex? Because if we can figure out the highest point, that would be our maximum possible value. That would be our maximum area. Okay, so find the value of x that maximizes the area for the figure. We need to start by finding the axis of symmetry. Okay, so what we're going to do here is I'm just going to erase this information real quick. So we have a little bit of space to finish this first question. We're going to take this quadratic, y equals negative x squared plus 9x plus 9x. The only difference in this is I removed the 1. We don't need to show that 1. So here's the quadratic we're dealing with. If we can find the maximum point, that's our maximum area, but we first got to find the axis of symmetry, the AOS. How do you find that axis of symmetry? We know it's opposite of B over 2A. Remember, opposite of B over 2A is what's going to give you that center of your parabolas. So this is my A, this is my B. We have no C, so in that case it's a 0. So here we go. Opposite of B, the B value is 9. How am I getting that? Just a quick review for you guys. Y equals ax squared plus bx plus c. Standard form of a quadratic. First term's your a, second term's your b, third term's your c. So 9 over, what number is this? This is negative 1. So 2 times negative 1. Why am I multiplying by 2? Because that's how we find the axis of symmetry. Opposite of b over 2a. All right, so 9 over 2 times negative 1. So this is going to be the opposite of 9 over negative 2. So what we're going to end up getting here is positive 4.5. So find the value of x that maximizes the area of the figure. If we build a garden that is 4.5 feet by 4.5 feet, that's going to cause this to have the most area as possible. Just like if you were building a home. If you were building some awkward L-shaped home like this, you want to maximize your area, square footage, you would use these values to maximize it if you were wanting it to have these ratios involved. All right, so 4.5 is what we would be using for x. Now let's find the maximum area that we can get out of this this figure that we're looking at. Okay, so now we just take the quadratic we already found, negative something squared plus 9 times something, just using this quadratic right here. Wherever the x's are, I replace with empty parentheses. I'm going to take that value of 4.5, I'm going to plug it in, and then I got to work this out. So now I need to take 4.5 squared. It'll become a negative value down here. Then I'm going to take 9 times 4.5. I'm going to get those two values, combine them together, and it will tell me exactly what my area would be. And keep in mind, this is the maximum area we could create. So let's start with 4.5 squared. That's going to give you 20.25, but we need it to be negative. Then we got to do 9 times 4.5. 9 times 4.5 is going to give me 40.5. Okay. Combine those together. A negative 20.25 plus 40.5 leaves me with 20.25 square feet. So the maximum area that I could get from a shape that has these ratios to it is exactly 20.25 square feet. Okay, hopefully this makes sense. So what were we doing? We're finding the area of this irregular shape, right? Once we get that area, we realize because of how it's given, we're gonna get a quadratic. And what's the neat thing about quadratics is we can find maximums, we can find minimums. In this case, we want to maximize our space. We can do that by just breaking it down, doing a little bit of algebra. Hopefully this makes sense. Study hard and good luck on your upcoming test.